So 3.6, sketching graphs. Page 209 has that whole list of everywhere to find everything. So the first thing we did was simplify. We factored so we could simplify. Nothing simplified out, so we wrote the domain. Next thing we need to do is x-intercept. Does anybody remember how to find an x-intercept?
Set it to 0.
Yes, you set it equal to 0. When I set it equal to 0, the denominator is going to 0 out, so it's essentially just the numerator equal to 0, correct?
Yeah.
So 2x minus 3, x plus 3 equals 0. So my x-intercepts are negative 3, 0, and 3, 0. So y-intercepts.
Set all the x's to 0.
Okay, all the x's to 0, and I think it's easier to come back to the original. Most of the things we do are with the simplified, but I think it's easier to come back to the original. So it would be 2 times negative 9 over negative 4. So 2, so 9 halves, I think.
Mm-hmm.
Okay, so 0, 9 halves.
I'm really proud that I remember that.
I know, you're doing good. Okay. And then we need to vertical asymptotes. Anybody remember vertical asymptotes? Where we get those?
I remember, but I can't remember.
Vertical asymptotes.
Wait, isn't that also the numerator? Okay, the denominator.
Denominator. Okay, because you use the numerator for x-intercepts, the denominator for vertical asymptotes.
So you set them equal to 0?
Yep.
Okay.
So x equals plus or minus 2. We write them like an equation because they're a vertical line.
Yeah.
Horizontal asymptotes, or your limits at infinity. That's what we went over.
Mm-hmm.
Okay, so remember that's a comparison of your degrees, numerator, denominator. So you have to come back to the original. So you have 2 and 2. So when the degrees are equal, what was the rule?
Oh,
0 when the numerator is less than.
it is leading coefficient.
Leading coefficient. Now, be careful because the leading coefficient on this one isn't 1, it is what?
2.
2. So 2 over,
1.
so 2. Okay, and then we need to do symmetry. Where do you want to put your graph? You want to put our graph here?
Yeah.
Okay. Oh, I don't feel like that's straight. No, that's pretty straight. Okay.
Wait, Miss May, when is there a slant?
When the degree of the numerator is greater by 1 than the denominator.
Oh, wait, how do we figure out the slant again?
This long division.
Oh, yeah.
Okay, so do you guys remember symmetry rules?
No.
They're way back in your P1 notes. Clear up.
Oh, we have to change, like, the x.
We have to change those. So we have to check x-axis, y-axis, and the origin.
Yep.
Okay. So What do you want to start with? Y-axis?
Yeah. The
Okay.
3 rules.
Yep. So y-axis first. So y-axis, you change the
X's.
x's. X-axis, you change the y's. And origin, you change
Both.
both. Okay. So
Are you changing it on the
we can do this one.
first one?
Yeah, that's fine. Okay. So I would have 2 times, well, negative x squared minus 9 over negative x squared minus 4. So that would give me 2x squared minus 9 over x squared minus 4. So that's a yes. But it also could be yes on other ones, right? So I have to check all of them. So x-axis. So it'd be negative y equals 2x squared minus 9 over x squared minus 4. But that negative would have to move to the other side, yes? And it would make this a negative 2. And is that the same?
No.
So then this is a no. Okay, and if it's not both, it's a no, correct? If it's not both. But we'll do it anyway just so you can see it. So origin. So negative y equals 2. And we could, I usually just put the answer I got here because that's what it's eventually, on y-axis, because that's what it's eventually going to be. But I'll do it all out so you can see. Guys, are parentheses very important when you're doing this?
Yes.
Yes, because without them, those x's would be negative, wouldn't they? Okay, so this would come out to be positive, but this would still come out, change it to a negative, so it is a no. So it is symmetric about the y-axis?
Yeah. So, wait, I forgot. Sorry, Riley. Oh, you're good. So, if, like, the x and y axis were both yeses, then the origin's going to be yes. But if there's one that's a no, it's always going to be no.
Yeah.
Okay.
But you should practice checking them all. Because if
Maybe
you
I'm
got
wrong.
yes, if you got yes, no, yes, then something went wrong.
Okay. Wait, and I get my yes and no's, like, because it has to equal the beginning one?
Yeah, it has to come out to the
And
original.
if it doesn't, that's when I get my no?
Mm-hmm.
Okay.
Other questions?
No.
Okay. So now we can put what we want on there, or we can go on. If it would make you feel better, we can put the x and y intercepts on there. Vertical asymptote, horizontal asymptote.
Do we not have to make that big chart anymore?
Yes, we do. We haven't even got to the calc part yet. Well, other than symmetry.
I really don't want to do this homework.
Okay. So 9/2 would be 4.5, right?
Yep.
Remember, when you're making your lines, if you make them about equal, it makes it a little easier to graph. Vertical asymptotes are at 2 and negative 2. And horizontal asymptote is at 2. Remember, horizontal only affects what? Does it affect all of it? No, it doesn't affect that middle chunk. It's end behavior. Limits at infinity. Got me? Okay. So now I need to do first derivative.
I'm gonna rattle. Wait, what does the symmetry part mean?
It's going to be symmetrical about the y, so it's going to be the same here as it is here.
Oh, so you kind of look at that at the end then.
Yeah. If what you draw isn't symmetric, like,
Then you did something
then you
wrong.
did something's not right. And like already we should know that this piece here is here and this is here because of that open door.
Yeah.
And something has to happen here. Okay,
Oh, wait,
but it
what-
can't cross here, can it? Why can't it cross here? Why can't it do this? What isn't there? There's no intercept. There's no open door. So something has to happen with this.
Oh, that's what happened.
But it may not be a parabola. Like, you know what I mean? It may come down and like have this weird shape and then go back up. That's what we're doing now. Because remember when I'd say, oh, that's for calculus to figure out?
Yeah, so now we're talking what's in there.
Yeah. Okay. So now we need to do the first derivative. So the first derivative, we are going to come back to the original.
Okay.
Okay. Can I move this up now?
Yeah.
Okay. I normally like to put my chart down at the bottom. So I think I'm going to do my derivative over here. Because I like to put my chart like across the bottom.
Is our chart our last thing?
Yeah. It's our interval analysis. So yeah.
Oh man. Yeah.
Okay. So, first derivative.
Wait, do we always do two derivatives now?
Mm-hmm. You do the first derivative and find your zeros for your critical numbers, and then your second derivative.
How do you know if we ever have to find more?
You won't.
We won't?
Not for this. It's just first and second.
Okay. I got it.
I'm rewriting this as 2x squared minus 18. You guys good with that?
Oh, yeah.
I probably just made it worse on myself, but. Oh, shoot. Okay, did you guys get 20x over x squared minus 4 squared? So now I need to set that equal to 0 and find my critical numbers.
Yep.
So when I do that, the denominator is going to zero out. So it's basically 20x equals 0. So x equals
Negative.
0. Okay. So now I need to find the second derivative. Don't forget to use your chain on that denominator. Okay. Did you get negative 20 times 3x squared plus 4 over x squared minus 4 cubed?
No, how'd you get the, so I got the 20x squared minus 4 squared, but how'd you get the 20 and then the parentheses 2x? So you just moved down the 2 in front of the x squared?
I did the chain rule on the denominator. So I said don't forget the chain rule. Because the derivative of the denominator would be 2 times x squared minus 4 times the derivative of x squared, which would be 2x. Okay? So now I set that equal to 0. And then it's just going to be this 3x squared, correct?
Yeah.
So it would be x squared equals negative 4 over 3. And this is the possible points of inflection, right? And can you take the square root of a negative number? Nope. So it is a none.
So you found that by setting it equals 0, and so then it's really the 3x squared plus 4.
Yes.
Okay.
Because when you set the whole thing equal to 0, the denominator is going to zero out. Then you're going to divide by 20, and you'd be left with 3x squared plus 4. So there is no change in concavity. That's what that tells you. Because there's not even because the possible points of inflection is where it may happen, right? But this doesn't have any. So we now come to our intervals. So our intervals, we got our vertical asymptotes. I like to put my x-intercepts in there. If you look in the book, they do not put the x-intercepts in. Okay? How do you guys feel about that?
Put them in.
Okay. So
I
x.
feel like I gotta do everything, or I will like.
Okay.
Skip it and I.
So x-intercepts, vertical asymptotes, critical numbers, And then possible points of inflection. I mean, if there's a none, then it doesn't do anything. Okay? So, looking at your numbers, sometimes it's handy before you start writing your chart to kind of break up your number line. Does that make sense? So, let's write them in order. So what is your smallest important thing? Let me get rid of the
-3.
-3. So just make a little list. So -3. And then maybe I'll just put intervals. Okay. So -3. Then what's my next one?
-2.
-2. And then?
0.
Mm-hmm.
2.
Mm-hmm.
3.
And 3. So this was an X int. This was a vertical asymptote. This was a critical number. This was a vertical asymptote. And this was an x-intercept. Not always going to be symmetrical like that, but is that helpful to know what's actually going on in my chart?
Yeah.
Yes, because a critical number is going to be a relative min or max, right? A vertical asymptote is going to be an undefined.
So in your intervals, you don't have to, you only include the ones that we start on the
Yes.
size. Okay.
Possible points. And anything in your domain that's not here, that's not in your vertical asymptote. Okay, because remember, critical numbers are zeros and undefineds. And I didn't point that out because what is still undefined here? Plus or minus 2, and where's it at? There. Because plus or minus 2 would make that undefined, yes?
Yeah.
But do I already have it covered?
Yep.
Does that make sense? Okay, so now let's make our chart.
That's the last thing I have to do.
Uh-huh. Well, and then graph.
I'm running out of work.
Me too. Oh.
Okay. So, negative infinity. Oh, let me do. Okay, so here. And then I like to put an X column, but that's just me. You don't have to. I'm not going straight. Oh, that's horrible. I can't do this. Okay. So interval x, f of x, f prime of x, f double prime of x. And your decision, your conclusion, characteristics on the graph, what do you want to call it? Graph?
Yep.
Okay.
But is that the same thing as conclusion?
Yep. Okay. So we went through my graph. My table is absolutely horrible. Okay. We went through when we made it, so we're going to go negative infinity to -3. And then -3. And you guys probably have lines, don't you?
Yeah.
Okay, and that was an x-intercept. So you're going to write x-intercept over here on the graph. So if it's an x-intercept, am I going to put it into any of this stuff?
No.
The only thing I would is maybe f of x, so I'd have 0. So it'd be -3, 0. Because that'd be the point, right? But everything else just has a line through it. And make it a big line so you don't think it's a negative. Okay? So then I go -3 to 0. And x equals 0. And what was that?
Are you not going to put -2 in there?
She said 0. I just wrote 0. Okay. -2 is a vertical asymptote, yes?
Mm-hmm.
So this is undefined. And we just write over here what? Mm-hmm. Oh, next time I'm doing lines. Especially when I don't feel good. Okay, and then -2 to 0. And x equals 0 was a critical number. And I write critical number here off to the side because that could be a relative min or max. We don't know which one. Okay? So then 0 to 2. And x equals 2 was vertical asymptote. No, I did too. I'm writing kind of big because you guys are looking at it. And then 2 to
3.
and x equals 3. And that was an x-intercept. So 3, 0, x-intercept. And the last one, 3 to positive infinity. So we need to come up here. Okay, so we have that it is, this right here came from an x-intercept, so we're only doing like positive or negative. So I'm not going to do first or second derivative. So I need a number in between negative infinity and -3.
-5.
Okay, so write -5. So you know, it gives you a point you can plot on your graph. So -5, and you're going to put it into the equation. If you want the point, you can have the point. If you don't, you can just do the positive and negative like we used to. Are we okay with just positive, negative for now?
Yeah.
Okay, so this would be don't forget the 2 is a positive, right? And then you would get a negative and a negative, and you would have a negative and a negative. So the whole thing is going to be what? Positive.
Wait, wait. How are you getting negatives?
Plugging this into here.
To the x's.
So that would be a negative, that would be a negative, that would be a negative, and that would be a negative. So you have 4 negatives, so the whole thing's positive.
Yep.
So that means if the graph is positive, so that means it's above the x-axis, right?
Yeah.
Which we already knew. Okay? Then it's going to go through the x-intercept, and it better be negative because it wasn't a double, right? So negative infinity to -2. And we are going to check our concavity in that with this one. So we're going to do it on all of them. So -3 to -2. What do you want to pick? Negative, well, 2.5. So at -5/2. So that would be a positive, be a negative, positive, negative, negative. So the whole thing would be a negative. Okay, so it's negative. Okay, we're going to go first derivative. So that I would get a negative over a positive. Don't even have to plug it in because I'm squaring it, right? See that? So the whole thing is what? Negative. So that means the graph is decreasing. And then second derivative. Come over here to the second derivative.
Are you putting that into the answer you get?
What?
Are you putting those into the answer? Oh, wait, yeah.
Yes. Okay, so then right here, second derivative would be negative because of 20, right? It'd be positive because you're going to square it. This is where number sense comes into play, right? And, well, when we square 5/2,
Why is the 20 negative?
because it's negative over here. I factored that.
I thought. Oh no, never mind.
Okay. And then this would be a positive down here. And so the whole thing is negative. So that is concave what? Down. So what that looks like here, we said it was positive, we said it was negative, and it would go so isn't that concave down? Yeah. So that's how you're going to do that chart. You're going to step through it. Okay? Now, these problems take a long time. That's why you don't have very many, and you have the whole rest of the week. So get them started. If you get them to your chart, a bunch of them, then that gives you a place to start tomorrow. Okay?